Hey there, and thanks for tuning into Everything AI.
Great to be here.
Today, we're really diving deep into the story of artificial intelligence. We want to trace its journey, from the very first sparks of the idea,
Right, the absolute beginnings.
all the way to the incredibly powerful tools we're seeing emerge right now.
Exactly. And our goal in this deep dive really is to uncover how AI moved from being, well, almost science fiction, just imagination,
Yeah.
to a technology that's actively reshaping our world. And maybe the most fascinating part is exploring why it's accelerated so much, so dramatically recently.
I think people might be surprised, actually, how long this dream of AI has been around and the sort of pivotal moments that led to this current, AI revolution.
Absolutely. It's a longer story than many realize.
Okay, so let's kick things off way back. Before computers as we know them even existed, right?
It's quite remarkable, yeah. The basic desire, the idea of creating artificial intelligence, it isn't really tied just to computing. This human fascination with making artificial beings, something that could mimic or maybe even beat our own intelligence, that has roots way, way back. History, even mythology.
Like the ancient Greek myths, you hear those stories, right?
Yeah.
Self-moving machines, automatons,
Yeah.
often made by the gods.
Exactly. Now, obviously not thinking machines like we imagine today, but those stories definitely point to this long-standing human curiosity, this desire to create artificial life or agency.
Okay.
And then if we jump forward like many centuries, you start seeing this philosophical side take shape. Ramon Lull in the 13th century.
Right.
He actually envisioned machines capable of reasoning. Now, it was very abstract, philosophical,
Sure.
but it shows an early attempt to imagine intelligence in a, well, mechanical form.
And then much later, the 1800s, Ada Lovelace.
Yeah.
People know her for the analytical engine work.
With Babbage, yeah. But what's really insightful is her vision beyond just calculations. She imagined machines creating art, like music.
That's a huge leap thinking about creative potential back then.
It really is. And you have to wonder, what's the driver behind all this? For centuries, I think fundamentally it boils down to that core question. Could a machine actually think? Could it replicate us? Maybe even do better?
Okay, so the dream is ancient. Let's shift gears now to the more modern origins. And for me anyway, that has to start with Alan Turing.
Oh, absolutely. Turing is foundational. 1950, he asks that incredibly direct question, can machines think?
Yeah.
And crucially, he proposed the Turing test as a way to maybe answer it. It gave us a practical benchmark, a way to evaluate if a machine's behavior could be mistaken for a human's.
And then just a few years later, what many see as the official starting line, the 1956 Dartmouth Conference.
Right. That's where you get figures like John McCarthy, Marvin Minsky, key pioneers. It really established AI as a formal field of study.
And the mood there, it was incredibly optimistic, wasn't it?
Oh, the optimism was palpable. These were brilliant people who genuinely believed that the main challenges of AI could be largely solved within, say, a couple of decades.
Wow. Decades.
Yeah, there was this real buzz, almost a sense of limitless possibility.
So what was their first approach? How did they try to build this intelligence?
Well, the initial focus was very much on symbolic systems. So think about programming intelligence by feeding machines explicit rules, logic, decision trees, things like that.
Did it work?
In very specific, narrow areas, it actually showed some early promise, yes.
What?
But as soon as these systems bumped up against the messiness of the real world, their limitations became pretty clear. They struggled with ambiguity, with the sheer amount of information needed.
Right. Which kind of leads into that first big wave of excitement, the 60s and 70s. It felt like AI was really taking off.
It did. We saw programs playing checkers, even proving simple math theorems.
Yeah.
These were seen as major steps forward.
But then the hype cooled down. We got the AI winters.
Exactly. That initial excitement was followed by a significant downturn, maybe two main periods, in the 70s and 80s. Funding for AI research really dropped off.
Why? What went wrong after all that hope?
Well, several things. Like we said, those early systems just couldn't cope with real-world complexity. They were brittle. They worked in the lab, but fell apart with messy data or uncertainty.
Any other factors?
We also just didn't have the huge data sets we have now or the sheer computing power needed to train more complex models. The hardware wasn't there yet.
But it's important, isn't it, that even during these winters, the research didn't totally stop.
Crucially, no. Foundational work kept going, sort of under the radar. Key ideas were being developed, things like neural networks, expert systems, quiet progress.
Laying the groundwork for later.
Precisely. Those persistent researchers were building the theoretical tools, the understanding that would eventually fuel the next big wave. Which brings us really to the 2010s and the deep learning revolution.
Okay, this is where things really start to take off, speed-wise. And that 2012 ImageNet competition seems like a key moment.
Oh, absolutely pivotal. Jeffrey Hinton and his team won it using AlexNet, a deep neural network. And it wasn't just a small improvement. It was a massive leap in image recognition accuracy. It just blew the previous methods away and made everyone sit up and pay attention to deep learning.
And a big part of that was the hardware catching up, particularly GPUs.
Exactly right. Graphics processing units, GPUs, designed for graphics, turned out to be amazing at the parallel calculations needed for deep learning. Suddenly, training these huge, complex models became feasible, faster, much more efficient.
So better computers?
Yeah.
But you also needed the fuel, right? The data.
That's the other half of the equation. It was this convergence. We had these vast amounts of data pouring off the internet, big data.
Right.
Combine that with smarter algorithms like deep learning and the powerful computing hardware. It was a perfect storm. Suddenly, AI started getting really good at things that used to be incredibly hard.
Like understanding images, computer vision.
Huge breakthroughs there. And speech recognition finally became usable in everyday tech. Language translation got way better, too.
And that was really just setting the stage for what came next with language itself.
Which leads us right to the next massive leap, the transformer architecture. 2017, Google researchers published Attention is All You Need. Catchy title.
Yeah.
And genuinely revolutionary for natural language processing for NLP.
So how did the transformer change things for understanding language?
Well, basically, unlike older methods, it allowed AI models to weigh the importance of different words in a sentence or paragraph, to understand context much better.
So it could figure out which words really mattered for the meaning.
Exactly. It gave the models a way to sort of pay attention to the relevant parts, grasp nuances, long-range dependencies in text. It was a fundamental shift.
And that architecture became the foundation for these huge language models we see now. GPT-2, then GPT-3, GPT-4.
Precisely. You saw this rapid scaling. GPT-2 in 2019, impressive. GPT-3 in 2020, a huge jump in capability. Then GPT-4 in 2023. The progress has just been exponential.
And the range of things these large language models, LLMs, can do now is just staggering.
It really is. Writing different kinds of text, generating code, debugging code, summarizing complex reports, analyzing data. I mean, in some cases, performing these tasks at human level or even beyond.
And it's not just raw intelligence, is it? It's also the scale, the speed, and how accessible these tools are becoming.
That's a really crucial point. The impact isn't just one thing, it's this combination. So maybe we should quickly recap those key factors that came together.
Good idea. So first, the computing power. GPUs, specialized chips like TPUs.
Yeah.
Just way more muscle.
Yep. Then the data. Unimaginable amounts of text, images, video from the internet feeding these models.
And the algorithms themselves. Deep learning was huge. Then transformers, and also methods for refining them with human feedback.
Right. Techniques like a reinforcement learning from human feedback, RLHF, making them more helpful and safer. Plus, we can't forget the role of open source.
Oh, yeah, that's huge. Sharing code, models, research, it just speeds everything up globally.
Massively. And then layer on top the economic factors.
Yeah.
Huge venture capital investment, intense global competition, pushing innovation forward.
It really is a perfect storm.
Huh.
So where are we right now? What's the state of play today?
Well, AI is moving firmly out of the lab. We're seeing practical applications everywhere,
Right.
building websites automatically,
Passing tough exams like medical boards.
composing original music, generating video.
Yeah.
The capabilities are expanding incredibly fast.
And it feels like AI is shifting into this role of being a co-pilot, an assistant,
Yeah.
maybe even a collaborator.
That seems to be the direction, yeah. Augmenting human abilities across so many fields.
But this speed, this power, it brings up some massive questions, doesn't it? Big challenges.
Oh, absolutely. Huge questions. How do we ensure these powerful systems are safe? What's the impact going to be on jobs, on the economy?
What does it mean for creativity? How do we regulate this ethically and effectively?
And then the deeper philosophical stuff, consciousness, the nature of intelligence itself. We're wading into some very profound territory.
It definitely feels like we're just at the start of something massive, and the future path, oh, it's wide open. The pace is just breathtaking.
It really is. The journey from those ancient myths to today's AI. It's been long, complex, full of ups and downs, but this current convergence of factors is just undeniable.
Well, that just about wraps up our deep dive into the history of AI for today. Here on Everything AI, we've covered a lot, from those earliest concepts right up to the present day, and the key things driving this boom.
It's been fascinating to trace, and next time on Everything AI, we're tackling something maybe a bit more unsettling. The question is, should AI sound human?
Ooh.
We'll get into the ethics of AI voices, personality, digital clones, all
Yeah.
that complex stuff.
Sounds like a really important discussion. So if you enjoyed this look back at the history of AI and technology, please do subscribe to Echoes of the Past wherever you get your podcasts. You won't want to miss our future explorations.
Absolutely.
Thanks again for joining us.